Welcome to all the global users, open source community all over the world. Good morning, good afternoon, and good evening, wherever you are. Thank you for joining CDAP Day on Google Open Source Live. If you haven't attended one of these sessions, our open source live events before, it's a monthly web series where each month we explore a different topic with open source. Today, of course, it's all about enterprise data integration and Cask Data Application Platform, CDAP. My name is Chaitanya. I lead the data integration, data movement, and data ingestion product management at Google. As part of our enterprise data integration portfolio, we have Cloud Data Fusion, Data Flow, Data Stream, Data Form. We offer a lot of different technologies, but it's not about Google's technologies today. It's all about open source. It's all about CDAP. Today, we are going to talk about, we have got some exciting sessions lined up for you from a lot of different expert speakers. We are going to talk about the future of data integration with CDAP. How do you build ETL pipelines in CDAP? How do you actually performance tune these pipelines in CDAP? And then finally, we'll finish off by learning how do you actually manage plugins and the life cycle of a plugin on the CDAP ecosystem. Now, because I am the MC, I get to choose who goes first. So I'm going first. I'll walk you through the session of future of data integration with CDAP. But before that, let me talk about a few housekeeping items for us. Do not forget to put your questions on live Q&A forum below the live stream, because all of our speakers are ready and available to answer all the questions. So if you are viewing this in full screen mode, exit out of full screen mode to see the live Q&A forum, and then you can actually ask questions and your questions will be answered in real time. Now, all of our sessions are pre-recorded, which means that we want to make sure that there is accurate transcripts for everything, so that the speakers are completely focused on you to help answer all these questions, all these great questions that are going to come today. Once we are done, do not forget to join our after party. We do have a party. You will see a button to join on in the event page at the end of the last session. Please join. And last but not least, we want your presence in social media. Please use the hashtag Google OS Live, hashtag CDAP. Share your experience, on LinkedIn, Twitter, TikTok, Instagram, Snapchat, or any other social media that you have. With that, let me start with my session. I'll take it away. All right, let's talk about what Cask Data Application Platform future is, and what are we thinking about from a vision and strategy standpoint. Again, my name is Chaitanya Paidimukala, part of the product management team, leading the data integration portfolio here at Google. Let's just dive right in. Right, there are some challenges when it comes to data integration. So, the three biggest things, and if you have seen the evolution of different data management systems and integration challenges, these kind of have stayed the same, and sometimes they have even compounded because of the fragmented landscape in the data management. First, I think we all know that it's extremely hard to find the right data in an enterprise. So if you want to look for the data, you don't have a single place where you can go look for the data, and that means that integration becomes all the more complex. The second challenge that we face in the market and in this space is that the technology landscape is always evolving, so it's never stagnant. So for example, you can go back and look at the mainframe days. There are still companies that are running their primary business on mainframes. Then we saw the whole evolution of databases, data warehouses, data warehouse appliances, big data systems, and then now we are actually seeing another wave of cloud native data management systems. So the technology landscape is evolving, and the way you process the data also continuously evolve with this whole evolution. So different programming languages, different ways to process the data, in real time, in batch, in continuously, for operational intelligence. This is also evolving. The other important thing that a lot of times customer do suffer is ensuring the quality of the data, transparency, and traceability of the data, because they are very, very complex problems. So if you are looking at any landscape, you have a multitude of systems where the mission critical data is spread around. And in order to find the right, good data that actually you can use to get insights is always challenging. There is no transparency in where you can get the data, who is accessing the data, where is the data coming from, what is happening to the data. So these are like the foundational challenges that are faced by any enterprise today who are dealing with data. What we have, at Google, what we have done is, we are actually putting a lot of weight behind our Cask Data Application Platform framework. Now, CDAP has been around for a long time. It was actually created with a vision to enable anybody who was trying to build data applications easily, without having to worry about the underlying system that they are actually building it on. For example, 10 years ago when Hadoop was really big, there were a lot of customers and users who were trying to build big data applications on Hadoop, and then lo and behold, at some point Hadoop became really obsolete. And when that happened, the challenge is that, when you build these applications that are really tied and not decoupled with the underlying systems, and they are actually coupled with the implementation, it's very hard to move forward. And when a new evolution happens in the technology space, it's not easy to port this application. So CDAP was created, by the founders, this with this in mind, the key principle in mind, that we need to keep it open. We need to make sure that all the applications that customers are going to build are portable. So when I say applications, I'm talking about, primarily around integration applications. So we have taken the same vision, and we are continuing with the same vision, as we are actually, one of the biggest sponsors for this open source project. We want to provide customers with a open source based enterprise data integration platform, and make sure that this is a single platform that can give a comprehensive data delivery capabilities, with activation of metadata, and with AI and ML assist. And on top of it, we want to make sure that, the entire platform is microservices enabled, so that you can actually build and scale integration applications. Now, the platform will shield you from all the, technology specific implementations, and then it'll allow you to seamlessly transition into whatever technology you want. And I'll talk about a little bit more about this. So our vision has stayed intact. We haven't changed our vision. We want to ensure that we continue to provide, every single user, and enable every single customer to be able to build and scale this large data integration applications. Now, when you go back and take a look at, data delivery patterns, and how there are, various data delivery patterns that are being used by users and customers. First is, there is bulk ingestion. Typically this is a pattern that customers tend to use for data lakes on big data systems, for to enable data science use cases, where you are doing large scale ingestion of not just critical transaction data, but there is also a lot of processing of social and interaction data. So that's the, one of the delivery patterns. Then the second and third delivery patterns are kind of similar, ETL and ELT. I know we kind of use it, um, you know, um, in various different contexts, but if you look at it, there is this pattern is actually to support building of enterprise data warehouses, data marts, data lakes, and what you are trying to do is you are extracting the data, you're transforming the data. Sometimes you are transforming the data in the system where, the data is being extracted. Sometimes you are actually pushing down these transformation capabilities to the underlying data management systems or the target systems, to actually optimize for cost and, performance. And you also need a visual mechanism to actually do this. Now, you want to, one of the key things with the CDAP platform, that when we started, looking at closely, is we want to support all these patterns and all these data delivery patterns in a single platform. So you can actually build an ETL pipeline within the Cdap platform. But you could also build, very specific, push down capabilities and ELT based mappings within Cdap platform. Like you can actually take a join and push it down. Then the other two modes are on the real time. One is replication. I want to really define what replication is and what streaming is. In traditional sense, when we talked about replication, data replication stands for change, capturing the changes from the underlying operational databases. So that's what customers do: is take this mission critical systems, take the change data, and then move it in real time for a lot to actually light up a lot of different use cases. They can be data consolidation, it can be operational reporting. Some customers actually do really do the database migrations with this. There are active passive systems that are getting built, but replication is one of those data delivery modes that a platform should enable, so that you can actually seamlessly stream data, and the log changes based on the changes that are happening on the operational database, and stream it into another operational database if you need it, or even a big data system. So data replication is, again, going back, it is real time, but it is mostly to do with mission critical operational data. Then you also have this capability around streaming. Now, streaming is, nowadays, I think there is a lot more data that is actually very, very fluid, and it is always moving. What I mean by that is, typically if you go back and look at your operational mission critical data, it changes, but new orders might come in, but there is a constant feed of other information that's coming in through either social networking sites, or your IoT systems, your edge systems, where a lot of this data is being streamed in, and it provides a lot of insights into how your business is running, how your operations are running, how your what are your customer satisfaction layer levels. Are there any challenges with the supply chain systems? So all this data should be collected and should be able, yeah, and the system should be able to analyze this streaming data in real time for operational intelligence. So that's another data delivery mode that the Cdap platform supports. And finally, when I talk about bulk data movement, it's just that it's not for ingest, but you want to be able to move data in batch for from applications, from relational databases, from flat files, either to actually create a staging location to actually power the downstream data warehousing or data mart use cases, or just to make sure that the data is available to various stakeholders within the organization. So one of the key things that we have done with the CDAP platform is to ensure that you are not looking at different tools for each of these patterns. Rather, you're actually looking at a single platform that supports all these data delivery modes. If you go back and look at what kind of capabilities does the CDAP platform offer, so one of the things that we have done is CDAP data integration capabilities are built for cloud, hybrid, and multi-cloud environments. And I call enterprises always, because you can actually operate CDAP at enterprise scale. There are a lot of enterprises that are actually using the CDAP platform to build into integration applications, or integrate all kinds of data, or democratize the data and make it available. So you can take this platform and you can obviously run it on Google Cloud. Um, you can also take the same platform and run it on your on premises. You can run it in multi-cloud environments, hybrid cloud environments, and that was the intent. So we didn't want to lock down to a particular infrastructure, but give the flexibility to the user to be able to take this and deploy it anywhere. Then the other important capability that we have in the product is we create user experiences for various user personas, for various to actually enable various different use cases. What I mean by that is, the same platform can be used by your traditional ETL developer, or a data engineer, or a citizen integrator, or an operations person to be able to actually solve a particular use case, whether it is data warehousing or streaming analytics or data marts or data lakes, with a single platform. So you can actually take this platform and solve all these use cases, but the platform's experience is also very different depending on what your user persona is. So I'll talk about user personas in a little bit in detail in the next slide. But I think the key thing is you don't have to go to another user experience, another tool to actually enable a different persona. You can actually stay in the same platform to enable all these personas. We also have ensured that we are offering comprehensive connectivity capabilities. Now, this doesn't seem like a big differentiator, but one of the key challenges a lot of the customers have is every customer, every user is different. And what I mean by that is everyone has some sort of different variation in terms of where they store the data, what their data management systems are, whether it's a different type of database or different type of application. Now, what we have tried to do is we have built more than 200 connectors to all these systems, including mission critical systems, the social systems, the mainframes, applications, and you can actually use these connectors to connect to any of these systems and to deliver the data in any delivery mode. So you can actually stream data for databases, or you can actually bring in data in batch from a lot of different databases applications and move them. Then the other important thing that we have done in the product is the product, actually one of the key things, it's not the product but the platform itself. What we have done is we have made sure that we have embedded AI and ML capabilities without having users to think about what AI and ML is. What I mean by that is, one of the challenges that we have is all this is a common problem. All the customers, and all the there is a lot of technology evolution that is happening, and you will always have a shortage of resources and skills. So now we are using a lot of everything is around AI and ML, and in order to actually go and hand code this AI ML into a platform is not going to be easy. So one of the things that we have done within the platform is we actually enable AML in the background so that you can actually do lineage of information. You can actually discover, and we can actually do some semantic inference of what kind of information that you are dealing with without having to go back and code. And we also offer various capabilities around taking voice and turning it into data, taking processing images at scale. All that is built into it without having to write a single line of code. Then finally, I think one of the things that we also enable is you can use your CDAP as a tool, and it's absolutely fine, and say I want to use it for ETL, building pipelines. But you could also actually go and start building your custom integration applications, which means you don't want to use the user experience. Everything is microservices enabled. We have SDKs for everything. You can actually say that I'm going to create a new user experience for my customers to be able to solve a particular use case. And I think that's where the power of CDAP comes in, is when you actually look at the platform itself. It allows you to actually extend the platform and add things and provide new user experiences so that you are actually solving for your use case and not trying to solve for the generic use case at all, right? And I think that's where the capabilities come into play. Let's talk about personas, right? I did touch upon the personas earlier. One of the key things is that happens is there are a lot of different various personas in an enterprise. And you can have citizen integrators who are actually doing ad hoc integrations based on building a line of business data mart or trying to analyze the data, to a data engineer and a ETL developer who are doing comprehensive integrations between complex systems and transforming the data to load into enterprise data warehouses or building data lakes, or to a data analyst who actually is visually looking at the data and trying to see how I can actually change this data to ensure the quality is good. Can I add some rules to the data to actually transform the data in a visual fashion? And lastly, I think there is also data operators whose primary role is to ensure that the data is well governed, the end-to-end data lifecycle, the integration lifecycle is maintained properly, and it also is meeting the SLA, and they are able to manage costs. So I think one of the key things that we do with CDAP, it supports all these personas easily in a single, platform, so that each persona gets their own user experience. Now if you go back and look at how do we do it, right, it's not, the space is not new, data integration is not new. We've been doing data integration for a long time, and we've been moving data around it. But the reason why this platform is so important, and it becomes really really powerful, is that we built this thing on some key principles. One is to ensure that there is one platform that can truly empower all the personas. And we also wanted to ensure that there is a lot of business IT collaboration. So there are lot of times when you go into enterprises, things are lost between business and the IT, because business requirements are different. They need to be translated, and then IT has to actually figure out a way to bring in the data or integrate the data. Now it is one of the I think it was there was a research that was done a long time back. One of the things that the they found out was, typically a lot of things are lost in translation between the business and the IT, because of the way business thinks about data is very different. So you lose about 6 to 8 months in order to actually kickstart any data related project, be it enterprise data warehouse or data mart or data lake or provisioning this data. Because of the lack of communication and common understanding, there is a huge challenge. There is also the problem with point to point integrations that you build out, and that actually creates a lot more complexity within an enterprise. Um, and and because you are creating all these integrations and everything, there is a lot of complexity to manage these applications. The more importantly, I think the other important thing that customers and users are looking at is, they want this platform to perform and scale. So you want to make sure that and that has been on our in one of the key principles for us, is that this platform should be able to support terabytes, petabytes of data movement without having any glitches. And then finally, we want to make sure that any user who is using it, there is portability. Because one of the challenges that we always see in the market is, when you have new technologies come in, is there's always sort of like you're getting into um, a more tightly coupled way to solve these problems with a particular technology and with a particular infrastructure or a cloud. What we thought about it is, we need to make sure that there is portability. You can actually port these application platform to any hybrid multi-cloud environment. Not only that, let's say tomorrow you want to move from a unmanaged open source CDAP into a managed platform. We actually allow you to do it, so that you can actually port all these things without having to make a single line of and the way it is possible, because we have core services, and then we have the applications built on top of it. So you can run the platform, and as I said, in any cloud or on premises or multi-cloud hybrid cloud environments. And you can actually use any of these technologies that we have, like whether it is Hadoop, Mapr, Dataproc, Cloudera, Azure, AWS EMR. But the platform consists of certain key things. One is connectivity. All the connectors are available. There are metadata services that built into the product. That means, because when you build the integration applications, your metadata needs to be stored somewhere, it has to be managed somewhere. There are lifecycle management of applications, lifecycle management of pipelines. Everything is built into the product. There is a comprehensive security layer. You can not only take the base security layer, but you can extend it and integrate it with your own security. So for example, we have integrated with Google security model. But you could also take it and say, hey, you know what, I'm using a third party single sign-on model, and I want to integrate it with it. Absolutely, you can actually go and extend it. We also have capabilities where there are comprehensive capabilities around monitoring, management, and administration. And everything is powered through microservices. Microservices are at the heart of the CDAP platform, so that you can actually enable and start building applications. Now, what we have done is, out of the box, we provide certain applications to the customers. So we have a wrangling application which actually allows you to prepare the data. We also have a ETL ELT visual experience to create your ETL pipelines. We allow you to create certain business rules. You can also have, there are further, a lot more analytics capabilities that are available on CDAP, that you can actually take and start building applications. Now, you can use any of these applications out of the box, but you can also build your own application and then build your own user experience, and it becomes an accelerator in the platform. And you will see that, when we go into this further sessions, we will show you how this works within the CDAP framework. Now, I talk about open, I talked about your CDAP system services and things like that. One of the things that I wanted to talk about was execution environments. You can actually take this, and because everything gets executed on Spark, you can execute it on Spark, you can execute it on a standalone Kubernetes cluster, you can actually execute it on Google Data Prog, or, as I said, any other third party services. You can actually go and execute it. Now, you also, because everything is microservices, we have seen that there are a lot of a lot of people who are trying to take advantage of the flat platform, because this is an enterprise scale platform that is available. So it's so easy for anybody to go and start building. One such example I've cited over here, but anybody can go and build either a customer 360 application. If you want to build your own data provisioning system for your business, or data provisioning system for your customers, you can actually enable it. So you don't have to use the out of the box applications that we package, but you can actually go and build. And then the other important thing is, because we are a community and we believe in open source, the primary thing that we are doing is, all the experiences that we are creating, we are actually making them available first in our open source platform. And you can, as a user, you can actually build a new application and make it available to the community. And you can say that, we have a cool little hub which is like a marketplace kind of thing, where you can say, I want to add this so that people can benefit from it. So there are a lot of contributions that are happening all over the world, where users and customers are actually giving, and contributing to the platform itself. Now, again, going back to, I just want to touch upon the key features before we and one is, this is open source. We invest very heavily into open source from a Google standpoint, because we believe that you can build great technologies, but the greatness lies in the fact that the technology is available and to everybody in the world. So everything is based on open source. It's a hybrid and multi-cloud environment. It allows you to have flexible runtime, where you can take the workloads and run it, execute it anywhere. It comes up with comprehensive connectivity, and it has unified wrangling and pipeline. This is something that I touched upon. Business IT collaboration. A data analyst can go look at the data, wrangle the data, turn it into a pipeline, hand over it to a data engineer or an ETL developer, and then you can actually switch back and forth. And then it's completely metadata driven, which means that you have governance controls. You actually have pipeline lineage, which tells you where the data is coming from, where the data is going. So this makes it really powerful. And I think finally, I want to say, how much are we betting on this platform? At Google, we are betting on CDAP because we built our managed enterprise data integration platform, Cloud Data Fusion, purely on this platform. So what we have done in principle is, we are actually building the CDAP open source and contributing to CDAP, and then we are taking the managed components, making them available on Google Cloud. And this is where another one, the portability comes in, is you can build something on Data Fusion and then you can run it on CDAP, and vice versa. If you have a cloud, if you want a cloud managed platform that is truly powered by CDAP, you can actually use Cloud Data Fusion. So again, our vision and strategy stays the same. stays the same. We want to help everybody to have an enterprise data integration platform, that they can deploy anywhere. We will continue to provide our support to the CDAP platform and the CDAP users and the community. So thank you very much for listening to me, and hopefully there are a lot more great things to come on this platform. Hope you have learned a bit more about CDAP and also are excited about CDAP as I am. You and how we at Google are rallying behind CDAP to make it the true open source enterprise data integration platform. Next, we'll hear from Nidhi Moore, an entrepreneur and part of our product management leadership team here at Google. She's going to talk about how do we build ETL pipelines in CDAP. Nidhi, please take it away.
Hello, welcome to CDAP Day. This is Nidhi. We're very excited to bring you this particular session where we talk about how to build ETL pipelines in CDAP. Let's quickly look at what we're going to discuss today. So we're going to start with introduction to CDAP, what are CDAP pipelines, and then how do we build pipelines, test them, run them, execute them, and all of that interesting stuff. With that, let's start. What is CDAP? But before we start with, what is CDAP? Why do we need CDAP, right? So in the data integration space, these are some of the key challenges customers face. First is if you were to write code when you're bringing data from various different sources in order to, say, build your data warehouse, if you were to do all coding yourself, you do manual integrations, it's time consuming, it's error prone, right? Then because it's point to point, right? So what's going to happen is your it's going to be slow, it's going to be complex, and heavy amount of maintenance overhead is what customers will have challenge with. And then slower adoption because there is a limited resource availability, so time to market gets delayed, your time to insights get delayed, and because of the gaps which exist. Uh, and and finally what happens is you want to bring, say, data from one more extra source. Now it's not flexible, you have to write it all over again. And even from a strategic standpoint, if you have to uh, write it, if you were to do it in multi-cloud versus single cloud, your strategy changes. Your code yourself will not going to uh, work in the new environment. So you have to build it every time, and there's a high total cost of ownership because of all of these complexities, right? So that is why data fusion, or data fusion, is built on CDAP. So CDAP allows you to have faster time to insight, lower to TCO, and improve operational efficiency because you don't have to write code. You can pretty much drag and drop the pieces and achieve the data integration goal through CDAP. A CDAP, so let's quickly look at what CDAP is. So it's a unified integrated platform for tools and services, specially built to do your data integration analytics solution, whether it's on-prem or on the cloud, right? So CDAP allows you to have different execution modes, and that's where the flexibility comes in. While we're introducing CDAP, I want to also talk about application accelerator, as we call them. There are multiple accelerator. Wrangler gives you the ability to do data quality checks and data transformation while looking at data, right? Data pipeline allows you, so it's a pipeline studio, it allows you, it includes pipeline studios, so it allows you to create pipelines, run them, and all of that. These are some of the other accelerator available in CDAP. So with that, let's look at CDAP pipelines, right? So why do we use pipeline? So pipeline allows you to move data, wrangle data, cleanse data, and in order to create, say, a data warehouse or a data mart or data lake. If you look at the CDAP UI, these are some of the components of the UI. So you have pipelines, Wrangler, metadata, control center, hub, and all of that. Today, we're going to focus on pipelines because our focus today is how to build pipelines. So, in your pipeline application or accelerator in CDAP, these are few things you can do with Developer Studio. You can create the pipelines. With Preview, you're sort of testing what you've created. Then you can there's an ability to export. So once you create a pipeline, and this is what I meant earlier when I was talking about flexibility, you can export the pipeline and import it and do something else with it, so that you don't have to redo your work, if you will. You might have 20 different or 100 different pipelines, right? You want them to run in a certain order, and you can create schedules. So some you might create at 4 o'clock, 5 o'clock, and then you can manage the scheduling that way. And then you have the connectors through which you read the data or write the data into, or you perform certain action, and you can navigate between all of this. Now, let's dive deeper into the concepts of CDAP, right? So, in CDAP, we have applications, dataset, application templates, plugin, and artifacts. So, what are application? An application is a standardized container for defining collection of services and relationship between them. But what does it mean? Wrangler is an application. Now, it is responsible for managing the life cycle of the programs and data sets. Data sets are basically the way we store and retrieve data, right? So each data pipeline is converted into an application, right? And then deployed and managed independently. Uh, like I said, data set stores and retrieves data, and data sets are your names of reading, are means of reading the data from and writing to CDAP storage connectors. Application templates are basically user defined, reusable, reconfigurable patterns of an application. It's parameterized by a configuration, uh, and so that you can reconfigure it, modularize it, and all of that. So a data pipeline provides its own application template. And you can create these templates, or these templates are configured using Data Pipeline Studio and deployed as an application into an environment, right? Plugin is basically some customizable modules exposed and used by an application template. So plugin, there are various different types of plugins: source and sync and transform and all of that. So where you're reading, say you're reading from GCS, that's your source plugin. You're writing into BigQuery, that's your sync plugin. That's the way to think about it. An artifact can contain one or more plugin. The artifact itself is a versioned packaging format used to aggregate applications, data sets, and plugin along with associated metadata. So it's a jar containing Java classes and resources. If you put all of these concepts together, what happens is, what you see here is a CDAP allows you to create pipelines, deploy them, manage them, and monitor them by a way of using application templates, plugins, and the studio. Uh, with that knowledge, let's break it further down into how do we create, execute, and manage the pipeline. So, when we say pipeline, what do we mean? We essentially mean it's a series of nodes connected for flow of data between two or more places. If I were to translate it into sort of English, it means you're, say, reading from GCS. you're doing certain transformation and writing into BigQuery, right? So these are series of nodes connected for flow of data. So your data is flowing two or more places. So here in this particular example I gave you, it's only two places because it's flowing between GCS and BigQuery, but you could write it into multiple places. Uh, it automates the process involved in extracting, transforming, combining, blending, cleansing, validating, loading data for further analysis. Uh, think of data pipeline as DAGs, right? Which where each stage, which are the nodes in the pipeline graph, can be of different types. Uh, Data pipeline allows for a non-linear pipeline, and we're going to look at what non-linear pipelines mean. Uh, but at a high level, you can fork from a node where output from one node can be sent to one or more stages. If you look at a pipeline, there are essentially two types of flows of data. One is control flow, and the other is data flow. Like the name suggests, data flow is when your data is flowing between the nodes, and control flow is when no data is passing, but what's passing is actually the metadata. So only the control is passing from one node to the another. Uh, and control flow exists only for batch pipelines. There are two types of pipelines, batch and real time. Batch pipelines will terminate when the batch is finished processing. You can schedule them and it processes, like I said, it processes data in the batch. On the other side, real time is when continuous data is being processed. Quickly, data pipelines, the way they are represented is JSON specification, and can be exported and imported to another environment. Quickly on the code generation, Data Pipeline Studio generates JSON specification for pipelines and not code, and those are specific to CDAP. Only CDAP can run those JSON. So if we look at a pipeline, a very simple pipeline for an example, in Studio, we went and put a GCS bucket, brought a transform plugin, and connected it to BigQuery. What's happening is you're essentially, how to read this is you're extracting data from your GCS bucket, transforming the data, and then loading into your target, which is BigQuery. And along the way, if you see bottom half of the schema of the GCS output was offset and body, offset long and body string. After the transform, it changed, and now we have ID and name and city and state and zip, right? This is going a little bit deeper into the schema concept, but essentially it's the output schema of BigQuery connecting to cloud storage, and that becomes the input schema. Transforms, it's important to remember that transforms can mutate the schema, and sources like databases are responsible for mapping source structure and type of CDAP schema type. So here's an example of, if your data was coming from Oracle DB, how would you map the Oracle data type to CDAP schema data type? Now let's build a pipeline. But before we start doing that, let's look at the life cycle of the pipeline itself. So you start with develop. That's where you go to Developer Studio, and then you from Developer Studio you have the ability to preview, and you can iterate over this process for as long as you wish, or based on how complex your pipeline is. You want to build small pieces, test and repeat, rinse and repeat sort of that process. And once you know that you're ready with your pipeline, it is immutable, and you're ready to deploy, at that point you have an option of executing it right away or scheduling it for later, or weekly, or daily kind of a schedule. And with all those runs, or with every time the pipeline is running, you're able to monitor that run and all the runs in the past. And this is sort of the life cycle of the pipeline. Now, how do you build a pipeline? What you need to do is you need to go to a CDAP studio, and You have something called application template. So you're selecting whether it's a batch pipeline or a real-time pipeline. You can search the plugin. These are plugin bins. These are the plugins themselves. Like I said, the plugins are divided into multiple types, and based on what you want to do, you select the plugin. Here in this particular example, I've chosen a GCS file. Then I'm wrangling it and putting it into BigQuery. And once I do that, I have the option of doing preview. I can configure the compute profile, schedule it, deploy it, and all of that. So these are the types of plugin we had looked at just a little bit earlier: action, source, transform, analytics, sync, and post-run plugins. And these are, by the way, these are sort of the attributes of all the plugins. So you can configure them, you can write information about schema, you can modify that. I'll go quickly over some of these slides, but at a high level, what we're trying to convey with the way of these slides is uh, these DAGs are non-linear pipeline execution. So, including forking from a stage where output from one stage can be sent to two or more stages, right? Two or more fork stages then can be merged. So you can do very complex stuff very quickly with Cdap. This is going deeper into branching and merging example. I'm going to go quickly over this. Now, say you have data coming from GCS, you have passed the CSV, it was a CSV, and you have BigQuery, you want to join them. So the order of the connection does matter. So that is something we have to be careful of. Branching, so output can be branched to as many sinks as needed. So here the Wrangler output is being branched into both BigQuery and cloud storage. This is going into join. So when you join, right, joining of two or more data sets on key fields using popular SQL like, but what you're essentially doing is you're not writing complex SQL semantics. What you're doing is you're doing it through intuitive UI, where you say for impression, which is the top box, and for on the landing, what are the how you want to join them, these two, and this is your join condition. These are group by capabilities also available in your pipeline. It allows users to apply processing on the entire feed. So you can do sum and count and all of that on the fly in the pipeline itself. Uh, and we'd also looked at action plugins. So the action plugins are they're used to execute a predefined action before pipeline starts or after pipeline starts. So for an example, I ran a batch pipeline. Now I want to move the data or the files which I already processed. So I will write an action plugin to move or copy over data, or maybe run some scripts on a remote server. This is how, there's a capability in CDAP to do error handling. When you look at error handling, essentially there are two types of error which can happen: one while you're creating the pipeline itself, and second, deploying the pipeline. So during creation, you can have missing fields. You might not have put in the information in the fields when needed, and missing artifacts or invalid pipeline JSON specification while importing existing pipeline. So these are some of the errors which can happen while creating a pipeline. And while deploying, you can have invalid logical errors on individual plugins, or you can have invalid values for pipeline level settings, and those can be reported. This CDAP, like I mentioned earlier, allows you to schedule batch pipelines. So you can set this pipeline to repeat on certain times. In this example, we're seeing that this is running daily, repeats once, and starts at 1 a.m. Now that we've built, say, a pipeline, what's going to happen is you want to test it before you run it, so that and you're essentially ensuring that your pipeline is doing what you were intending it to do. This preview mode allows you to test the pipeline, but do not muck with the target source yet. So you're not writing anything to your destination yet. Uh, in the studio view, you can click on preview, and it gives you an input and output data. And this is where you check if your output is looking good. And then once you're satisfied, you don't need to modify your pipeline. You can go and run the pipeline. But before you run the pipeline, you have to specify what is the compute profile. And for each run, you can have a different compute profile. During the runtime, the users can run the same pipeline in different environments. So you can run it on Hadoop, you can run it on EMR, you can decide where you're running. And this is what we were alluding to earlier, where we said we have four different execution environment which CDAP allows. This is how you can, a plugin responsible for managing pipeline life cycle of resources is running is used for running pipeline. Currently supports three provisioner. This is how you profile. You can set the profile, and once you are executing a pipeline, it requires, like I said, it requires a compute profile, and a system-wide default compute profile is selected. But if you users can modify a profile attribute to without changing the global settings, right? Quickly, once we've run the pipeline, we need to executed the pipeline, we need to monitor it. And this is how you monitor it. You get to see runtime arguments, you get to see your logs, the status, the duration for which it is running, what was the start time, how many errors, and how many warnings, right? And on each node, you can see metrics, what's happening at a node level, and then you can see what the compute profile was. And if you look at this summary tab, we're going to go over all of this. If you look at the summary tab across the runs, you can actually get uh, the metrics across various different runs. So if you click on one particular plugin metrics is telling you that there are 24 records in and 24 records out, no errors were processed. If you look at the summary across the run, it's telling you here it's telling you last 10 runs, what has happened, how many times it's failed, logs and errors and number of records processed. This is the summary on the compute profile. This is how you can look at that. And this is a dashboard which provides the aggregated view of all pipeline activity across all pipeline runs within the last 24 hours. And then it also shows the 5 pipelines which are going to run in future. With that, I want to thank you guys for attending CDAP Day, and hope this was, as exciting for you guys as it was for us to bring this content to you. Thank you.
Thank you, Nidhi, for that amazing, insightful way to build pipelines. You just made it look so easy to build a very complex pipeline with all the transformation capabilities. So thank you, Nidhi. Now we have built the pipeline. So the next topic is, how do you take this pipeline and scale it and tune it so that you are actually able to process massive amounts of data? For that, I've got the right person for you, Vitali, who is our performance architect for Cloud Data Fusion and CDAP. He is going to talk about performance tuning of Cdap pipelines. Vitali, please take it away.
Hello, my name is Vitaly Timchishin, and we'll talk about Cdap pipeline performance. So first, let's start from what Cdap is. And Cdap is a data processing platform that can process data on compute clusters in parallel fashion. And parallel is a keyword here because the way Cdap reaches its high performance is by taking your data, splitting into small chunks that are usually named partitions or splits, and processing them in parallel. And we'll talk about batch pipeline jobs. And typical jobs time spans from minutes to hours. It takes few minutes to start a cluster, start a job, and then it's been processed. And you probably don't want it to be processed for days, because a job error would mean you would need to restart it from scratch. So remember, it's not seconds, not days, it's like minutes to hours. And what's important to optimize your job is cluster sizing. First of all, you should have enough data. If your data is really small and your jobs run in 3 minutes, 5 minutes, there's not much you can do to improve it. But if your jobs are larger, then often bigger cluster means faster processing. And first thing you should do before even increasing your cluster is to check your cluster CPU load. If it's high, if it's like 80% or more, then adding more machines will probably decrease processing time and increase performance. So how do we do it? And this slide is probably the most important slide of the whole presentation. I've seen so many times people did it wrong. On the right side, you see a cluster configuration. In this case, it's a Dataproc cluster configuration, but it similarly applies to Dataproc static clusters or head-up clusters. Generally, you have so many machines named workers, and each machine have so many cores and so much memory. And then you have a resource tab, where you specify how much resources to give to a single executor. Now let's step back. What is executor? Executor is a VM that actually processes your data. In Cdap, executor does not process things in parallel by itself. You need a lot of executors to do this parallel processing. So it's rarely needed to increase executor CPU more than one. A single executor will not use it. It will be just wasted. But what's important is to coordinate memory between executors and workers. Like in this case, a worker has 2 worker cores, so we probably want 2 executors to run on it, and it has 8 gigs of memory. So let's see if we can fit 2 executors into this worker. In our settings, a single executor has 2 gigs of memory, so 2 executors will take 4, plus about 25% of overhead for operating system. You get 5 gigs. So we are actually not using 3 gigs of worker node memory. So probably a good thing would be to increase executor memory to 3 gigs. But remember, you should not increase it more. If you set it in this example to 4 gigs or 5 gigs, it would mean that 2 executors cannot fit on your worker node, and only 1 executor will be launched on each node, and each node will be underutilized. And again, you will see it on your CPU utilization graph. So if your CPU utilization shows problems, first thing to check is this worker nodes configuration and executor configuration. Now, let's say it looks good, but your data still is not processed at the pace you need. Well, of course, there are cases where just network I/O dominates, or you are doing some REST calls. But very often you need to check if partitioning is done properly. And let's start from a simple case. In this case, we have a simple job that just takes data and do some transformations. No joins, no aggregations. In this case, the source data is split into these partitions. Like if it's files, it can be separate files, or if file is big enough, even a single file can be split into smaller partitions. But then our executors start taking partitions. Like 3 executor takes 3 partitions, process them, then each executor, as soon as it's done with its partition, it's taking next partition, and so on, until after we are done with all the data. Now, what's important? First of all, you need enough partitions to load your executors. If you just have 1 or 2 partitions, you will not load 3 executors, so again, your resources will be wasted. And as I said, a single file can be split, so you usually can increase your number of partitions. And it's actually good to have twice or 5 times more partitions to account for processing time differences. Even with partitions of same sizes, processing time can vary depending on compression, record sizes, and so on. So while one executor is processing a larger partition or slower partition, another executor can process 2 or 3 smaller ones. But remember, partitions have overhead. So you don't want to have millions of micro partitions because overhead will dominate and will eat all of your performance. Now let's recap. So for no aggregation joins use case, number of partitions is driven primarily by the source. And for some sources, like file sources that read, for example, from Google Cloud, it can be tweaked with max partition bytes setting. And it has a pretty reasonable default of 128 megs, so you rarely need to change it unless you have a really weird compression ratio, for example. Now, if your source does not allow to tweak it properly and you don't see a good number of partitions, you can use a repartition plugin, but you should remember that it's a separate step that will take extra time. So try it and see if it helps you. Now, let's switch to a more complex case. This is a join case, but it applies to aggregation cases as well. So to do joins or aggregations, we need to repartition first. So in this case, we have 2 sources that we want to join. And in phase 1, we repartition data from the first source into a new set of partitions. Why? Because we need partitions by keys or key hashes. So the first partition will have join key hashes, say from A to C, the second from D to F, and so on. Next, we repartition the second source in a similar fashion. And now, as we have all these partitions, we can start the aggregation or join. Each executor will take 1 partition from the left, 1 partition from the right that share same partition keys. And now it has a small data amounts to actually do the actual join and to write the data. And now it goes pretty much same. Each executor takes next pair of partitions from left to right, next one, until after all the data is processed. Now, what's important here? Now, partitioning is defined by executor engine settings. So it's not driven by source. Engine can define how many partitions do you want to create with these key hashes. And with Cdap 6.4 and DAP and Dataproc ephemeral cluster, we know how many executors you're gonna have. So we tell executor engine how many partitions to create. And you still need to customize it manually for static Dataproc clusters or Cdap clusters. There are 2 reasons for this. First of all, we may not know your cluster size, but even if we know it, we don't know if this cluster is shared between the jobs, if we can configure the job to utilize the full cluster. So for static Dataproc clusters or Cdap clusters, you would need to configure it manually. Now, what other impact does shuffle have? Main thing is that shuffle includes sorting, and you probably know that it's best when your sorting done in memory. As soon as your sorting spills to disk, your speed decreases a lot. And you would also see it by decreased CPU usage because your disk I/O will start to dominate. So as soon as shuffle is involved, you need to look not only on number of your executors, but on the size of your partition. Why? Because unpacked partition should fit in memory, or in case of join, a pair of partitions from left and right. So let's say you have partitions of 100 megs. It means that 2 gig executor can probably fit this partition pretty nicely. But what if your partition size is 500 megs or even a gig? You need more executor memory, so you need bigger nodes, or alternatively, you need more partitions. And it's fine to have like 10 Ks of partitions as soon as each one is not very small. Now, good thing about Spark 3 is that you can specify a range. You can say, okay, Spark 3 make from 100 to 2000 of partitions. And in runtime, it will check the amount of your data and decide some value in between that fits nicely. It works even better with Cdap because Cdap actually sets this range based on your cluster setting automatically for you for ephemeral clusters. Let's talk also about skewness. What the skewness is? Skewness is when one partition or few partitions is much larger than other one. And in this case, actually what you will see is that your data processing speed goes down, down, down towards the end of stage processing, and your CPU usage starts from high and then gradually decreases, sometimes often to none. And what can you do about it? One thing is to have many partitions per executor. As I said, like having 2 times or 5 times more is actually a good setting. In this case, while your large partition is processed, now another executor take 2 or 3 of others. But there is an extreme case, is when one key is very popular within data set. Like, for example, you're processing geographic data and you join by city and you have a New York City and you have tons of data attributed to New York City. Or you have some default value, like null. Like half of your data have null. So half of your data will be single partition because a single key always form a partition. You cannot send data with same key to different partitions because your join will not work. Now we have a solution for this. Starting 6.2 Cdap, you can enable distribution. It will actually multiply data on the smaller side of your join, but will allow you to parallel process this big partition on a larger side of your join. The downside is that you need to explicitly configure it. Now with Spark 3, it's done automatically. So as soon as one of the partitions is big, like say more than 256 megs and 10 times big than other one, the very similar mechanism kicks in automatically. You can still tune it. There is this skew partition factor and skew partition threshold in bytes, but you rarely need it. Why? Because the first mechanism still works. As soon as your partition size difference is less than 10, probably having many partition per executor will solve it for you. So these two things actually complement each other very good. So let's recap. First of all, monitor your cluster CPU usage for underutilized resources. Pay most attention to your executor and worker sizing, and use latest Cdap and Engine Spark version to ensure you have most tuning done automatically. That's pretty much it what I wanted to talk about. If you have any questions, feel free to contact me directly. I'll always happy to help.
Thank you, Vitali. You made it look so simple and easy to performance tune our pipelines. Performance and scale is something that all of our users constantly worry about because the data is growing exponentially. And I'm so glad that glad to hear that CDAP provides a terrific ways to tune and scale your pipelines and to handle that exponential data growth and make sure that you are meeting your SLAs. So that's phenomenal. Next, we'll hear from our development leadership team, Amit Virmani and Prashant, who are going to talk about plugin ecosystem. One of the key differentiators for CDAP is the plugin ecosystem, where it's not just the connectors that we provide, but we also provide a comprehensive transformation plugins and action plugins. So Amit and Prashant are going to walk us through the plugin ecosystem and how do you manage these plugins. Over to you both.
Hi everyone. Today we're going to talk a bit about Cdap plugin development. Cdap, as you all know, is an open source software that a lot of customers, a lot of people, a lot of developers use to do data analytics. Both Prashant and I are going to be co-presenting this. We are from the Cloud Data Fusion team in Google. So let's dive into it. What we will talk about today is we'll talk what plugins are, what are the different types of plugins that Cdap actually supports. We'll talk a little bit about how do you see the annotations on plugins, how to make sense out of it. We'll talk about what schemas, what records are, and how do they get used inside a plugin. Then Prashant will walk you through how do we develop plugins. So basically, how do you write different methods of writing a new plugin code? How do we test? How do we build? How do we package that plugin? He'll talk a bit about how does the UI look like for this? What documentation should we care about? And then he'll walk you through some of the best practices that we have seen through other developers, other users using this, contributing to our open source GitHub repo. And we'll leave you with some references at the end that you can then take a look at your own convenience once this recording and once this talk is available to you. All right, let's jump into it. So first, let's talk about what are plugin basics. If you see below, I have a screenshot from Cdap Studio, and you can see three boxes over there which defines how a data pipeline is actually architected. If you look at it closely, you would see that the pipeline is trying to read data from a GCS bucket, a Google Cloud Storage bucket. It tries to do some form of transformations using a Wrangler plugin, and then it's writing it back into a BigQuery, which is Google's data warehouse. This individual steps here is what we call as stages of a pipeline. And each of these stage is the usage of a plugin. Plugin is basically an extension to Cdap that provides a very specific functionality. It's a pluggable framework, so you can extend, you can write your own custom plugins, you can use our Java SDK to actually go ahead and implement these. These are all exposed by our Cdap platform, so we'll go into it a bit more. First, let's talk about what is plugin versioning and how do we actually release plugins. So for development, we allow customers or we allow users or developers to create plugin versioning with major, minor, fix version with a snapshot. Basically, we follow the semver versioning. And with a snapshot, any developer can use it for their own development, for their own testing. Once they are ready with all the testing, with the documentation, everything, and they're ready to release it on a hub, you can make it into a regular version. And at that point, your plugin basically becomes immutable. And if you look at our versioning system, like I mentioned, it just follows a semver. And the release on the hub is basically so that everybody who is using Cdap can actually see your plugins that are exposed or that are uploaded into a hub. Let's talk about different plugin types that Cdap supports today. So as the name suggests, sources lets you create plugins that you can read from some particular data source. It could be a database, it could be a file, it could be a data lake, it could be an application like, let's say, a Salesforce, Marketing Cloud, or it could just be a Salesforce application, and you can actually use it to bring in the data. Next, once your data is there, you want to write it somewhere, and that's what we call a sync. So you can have plugins which are writing to, let's say, a GCS or a cloud storage or a BigQuery, which is Google's data warehouse, and we have specific plugins for those, or you can extend to write it to your own particular sync. We have transform plugins, which are very useful when you want to manipulate the data or when you want to transform the data. As an example, let's say you may want to clone a particular column, or you want to transform something to a particular date type, and you can use these transform plugins. We have action plugins as well, which are used to define or to be able to take certain actions at the end of your pipeline. These don't really affect the data that itself flows through the pipeline, but they are very useful at the end. As an example, let's say you want to run a particular command or a particular stored procedure on a database, depending on what your pipeline's condition is, and they can be used as an action plugin towards the end of the pipeline. We have analytics. These are used to do joining of the data. So imagine, as an example, you're joining purchases data with customers so as to find out which customer did which type of a purchase. And these kind of plugins or the joining plugin can be used to actually do that. Error handlers are also very useful. If, let's say, you want your pipeline to emit or to redirect certain records which are in error mode or which couldn't be processed to a separate placeholder, you could use an error collector. And then later you can come back and say, oh, why didn't my particular record get processed? Maybe it was a problem with the logic, maybe it was a problem with the column, but you will not lose these records while your pipeline runs. Instead, they'll all go into an error handler plugin and you can actually look at it over there. The final two plugins are the alert publishers and the conditions. As the name suggests for alert publisher, you can use or you can create a plugin that alerts you on a certain action or a certain stage of your pipeline run. As an example, you could be sending an email notification if a pipeline failed or if a pipeline succeeded. Similarly, conditions can be used to separate out or branch out your particular pipeline into different formats. So, for example, you want to do a particular action when it's true versus something else when it's false. You could use a condition plugin to actually do that. These are some examples of plugins that already exist with Cdap that we ship with, and these are common across batch or real-time plugins. So, as the name suggests, a batch sync would let you write records in batches inside into a sync. Similarly, a Spark compute would let you do Spark operations on a input data format or a data frame, and then also would return you a simple RDD object. Next, let's talk about how do you define plugins, or when you actually look at a plugin, how do you know what is it actually doing? So simply, there are plugin annotations. An add plugin would tell you what the type of the plugin is. So as an example, like we talked, it could be a source, a sync, or a transformation. A name would tell you what the plugin is intended for. And like we saw in the previous screen, a batch sync exactly tells you that it is going to be doing writing records into a sync in batches. Description helps build a case for the plugin. So when your customers are looking for what a plugin is actually going to do, they're looking for some more details. Description will help you add those plugin information as well. And when Prashant will talk about it later, he'll talk about the best practices of what we have seen there. By default, every plugin property that is required are required properties. If you want to mark them as optional, you can annotate them using nullable so that those are not required at the time when the plugins are actually being executed. Macro is a very useful functionality to define a plugin annotation. So imagine you have properties that you cannot provide at run or at configure time the values, and they can be provided at runtime. You annotate those particular fields with that macro, and then they get evaluated at the time when the plugins are actually running or when the pipelines are actually running. As an example, let's say password. You don't want to define a clear text password during design time, but instead, anytime a plugin or a pipeline runs, you will be prompted to enter a password. You can define that and let the pipeline actually run. Now let's talk about what do the plugins actually do and how does the data actually get processed. So schema is a basic building block for a plugin, for a data inside a plugin. It defines the structure that gets passed between different nodes. Structures or the schema can be very simple, in this case, just simple property bag, or it can be super complex where it can have a nested property bag. And as an example that you see on the right hand side, it just shows you a mixture of both a simple as well as complex nested data types here. Since we are extensions of Avro, the simple data types that are defined in Avro are supported within our schema types. And you can take a look at this table at a later point, just to look at different data types that are defined here and how do we actually use them in the plugin. This gives you another example, like we have date, timestamp that are also supported through our plugin schema types. Next is a record. Now that we have defined a basic a basic building block called schema, how do these schemas actually get used? So the schemas are used within a record. A record would be a collection, or it would be a structured collection of all the schemas that are defined for different columns, for different fields that are getting used. And a record or a structured record is what either gets read from a source or get written into a sync, and you can use that to do your full data processing within a plugin. Next, we'll talk about creating a plugin. I'll then hand it over to Prashant to talk about that.
So now let's talk about how to write a plugin. The first thing you do is to define a configure pipeline method. This method is called once when the pipeline is deployed. And this is where you'd put in your validation logic for all of the plugin configuration. You'd also set the output schema here and register usage of any plugins that might be required, for example, JDBC drivers. It's important to note that macros are not evaluated when configure pipeline is called. You can call plugin config.contains macro to check if a property plugin property contains a macro or not. Next, you want to define the prepare run method. This method is called once per pipeline run at the start of the run. When this method is called, macros have already been evaluated at this point. So you can add validation for any config properties that have macros enabled. In here, you can also add set up inputs for your sources and outputs for sinks and register feed level lineage. You can also create any resources that may be required. For example, in the BigQuery sync plugin, you can create the target dataset if it doesn't already exist. Finally, you'd also create an initialize method. Initialize is called once per executor. Here you'd add any initialization logic, and if you need to cache any objects or state in the executors, you do that in this function. When initialize is called, macros have already been evaluated. Next, let's briefly look at action plugins. So an action plugin runs arbitrary logic at the start or end of a batch pipeline. You can have a pipeline that only has an action plugin and no sources or sinks. So to implement an action plugin, you'd need to extend the action class and implement a run method. So all of the business logic for your action plugin would live inside this run method. You can also implement the configure pipeline method where you'd add validation for your action configuration. Next, let's talk about building, testing, and packaging your plugin. So plugin is packaged as a jar and a JSON file. So the jar file contains user classes and any library dependencies. And the JSON file contains metadata about the plugin. So things like what are the range of Cdap versions that the plugin is compatible with. It also contains plugin documentation that's rendered in the UI and presentation information that shows that tells the UI how to render the plugin in the Pipeline Studio. So we can define compatibility of plugins with Cdap versions by specifying a Cdap version range in pom.xml. In this example, the lowest compatible Cdap version is 600. So we usually bump the lower bound when we add a dependency on a Cdap API that's present in a newer version of Cdap. So in that case, we'd bump the lower bound of the lowest compatible Cdap version in pom.xml. The upper bound is usually set to the next major version. So for current plugins, that would be 700 snapshot. So for unit testing, you'd add the hydrator test dependency in your pom.xml. The hydrator test dependency provides mocks for Cdap classes and various plugin types like sources and sinks. In the unit test, you can basically programmatically define a pipeline and provide inputs for each stage where you can provide the config values of config parameters, and then you can deploy and run the pipeline, and the pipeline will be executed in memory. So for example, like if you're say testing a transform plugin, what you could do is you could feed your input into a mock source plugin, which then connects to your transform, and then you can write the transform data into a mock sync where you can verify that the transform data is what you expected it to be. The hydrator test dependency also provides some test infrastructure to validate to verify that your config validation logic is correct. So you can verify that you're returning appropriate error messages for invalid user input, for example. You can learn more about unit testing by checking out the plugin development guide in the link below. Next, let's talk about presentation, documentation, and deployment. So the UI rendering of plugin properties is controlled by a widget configuration file. The file is located in the widgets directory, and the file has to be of the form plugin name -plugin type.json. So for example, for the GCS sync plugin, the path to the JSON file would be widgets/gcs-patch sync.json. So by default, properties are rendered as a simple text box in the user interface, but you can customize the presentation to use a different interface by editing the widget config file, and you can use a different widget, like you can use a drop down, toggle, radio button, or other element. To learn more about UI widgets and presentation, you can check out the link below. So plugin documentation needs to be written in Markdown format. The plugin documentation lives in the docs folder, and it needs to be written into a file which is of the form plugin name dash plugin type .md. So for example, if you're writing a file source plugin, then the path to the documentation would be docs slash file dash batch source .md. So plugins, Cdap supports deploying plugins either through the UI or REST API. To deploy through the UI, you can go to the Pipeline Studio and click on the plus icon on the top right, which launches a pop-up where you can click on the plugin upload button, which launches a UI wizard. And in the UI wizard, you can upload your plugin jar and JSON from your computer. Next, let's talk about some best practices. So we recommend that you validate your input configuration at configure time if possible. This is because it's much faster to correct invalid inputs in the Pipeline Studio, because the UI gives you an immediate indication of where the error happened and how to correct it. On the other hand, if your error is detected at runtime, you'd need to wait for the pipeline to finish running and fail, which can take several minutes. So it's much faster to fix any validation errors at configure time. So we recommend you add validation logic at that stage. In addition, we recommend that you add context to your error messages. So for example, if your error message just says field contains incompatible type, that doesn't really tell the user which field had invalid input or how to fix it. But on the other hand, if the error message says something like input field ID is a string but is expected to be an integer, please change it to integer, then that's an actionable error message that tells the user what exactly they need to do to fix their input. Now, some best practices for documentation. Include default values wherever possible. If you can't do that, then at least include a descriptive placeholder message. And for UI users, make sure that you document all of the config properties so that a new user can figure out what those properties mean and how to use them. And also include usage examples for your plugin in the documentation with some sample inputs and outputs, so users can figure out what exactly your plugin does. These are some resources to help you get started with Cdap plugin development. There's also some links to example repositories, plugin repositories that you can take a look at. Hope you find them useful. Thank you.
Thank you, Amit and Prashant. You just showed us there are so many plugins and how to manage them easily. One of the key strengths of Cdap platform is plugins, of course. There are so many out of the box plugins that you can actually go and leverage, but you can also build your own plugins. Every great event has to come to an end. That's a wrap, but it's not the end yet. We are going to have an after party. So please join us at the after party. Click the watch live button on the events agenda page and you will be redirected to Google Meet. All the speakers are there. We'll have some quizzes. There is no party that is complete without any quizzes. We'll have some interactive activities. We'll have some surprise guests that are going to stop by. While you are there, please make sure that you are active on your social media post about this event. We hope to see you all there. Thanks a lot for your time.